All right. So going off of what we talked about was all the last section of Module 5, you know, you guys should all be celebrating. We'll talk about, what's it called? The project coming up. So this project is going to be the most, like, I think, exciting in the way that you get to choose your own data set. You get to decide what the problem is that you want. So note that the project is completely available to you now, so you can check that out. Next week and the week after will be 2 weeks of project week, right, with office hours. So, you know, you guys do the usual thing and everything. So the thing about this is because you're going to get to choose your own, what's it called? Your own data set, right? So it's kind of important to know, like, well, how do you know what to choose for a data set? So thankfully, another instructor had put together a little presentation on, like, you know, how to choose a data set. So I'm actually going to borrow his little presentation to kind of talk about how to choose your different data sets. So before I share that though, just know that this project's going to be, if you read through the material, it's going to be basically you choose a data set. You're going to try to choose a problem to basically make a prediction. So you'll get a bunch of data and you're going to try to predict some target aspect, okay? And then you can use whatever machine learning algorithm we talked about in this past module. Note that there's a whole bunch of them. The first thing I would say recommending to you is figure out, are you looking at a supervised learning problem or an unsupervised learning problem? And once you decide one of those things, you'll know which algorithms you can use. If you have a supervised learning problems, what machine learning algorithms could you use? Someone say at least one example of a supervised learning algorithm. You guys have no supervised? So like one might be, for example, decision trees, right? Or random forest. Oh, sorry, Alec, were you going to say something?
Yeah, I was about to. Is k-nearest neighbors supervised too?
Yeah.
Yep.
Yeah, k-nearest neighbors, right? So that one's using, you know, basically you figure out what things are in different groups and use similarity of like how close they are together in that space to figure out if that should be in that group or not. So yeah, k-nearest neighbors would be the solution. Like I mentioned, random forests is a really useful like ensemble methods going forward for that. You can also do things like support vector machines, right? That would also be a supervised learning. Heck, you could use logistic regression. I know that's technically from the previous part, but you could technically use logistic regression to do that. Though I would probably recommend doing a different one, just because logistic regression can be a lot of tweaking and try to get that just right. Okay, but I would strongly recommend trying at least random forest. Random forest is a very strong, powerful one. Unsupervised learning, we have different clustering algorithms, so like dbScan, all those other aspects within that, I think within the clustering section. So those would be unsupervised if you didn't have labels already, okay? So, but now we have to figure out how to choose our data set. So I'm gonna show that presentation, and then I'll show you some places where you can find, there we go, we can find some data. So again, this is from another instructor. So I'm trying to resize it. There we go. Okay, this is from another instructor, so no, that's not my own. But basically how to choose it. Note that it says module 3 project. This is from version 1. So technically this should be saying, like, for us, module 4. Okay, so every time you see module 3 project, just replace it with, oh sorry, every time you see module 3 project, replace it with module 5, the one that we're currently on. Okay, so just kind of going through this presentation, I'm gonna go through really quickly. I'm gonna skip over those parts. But basically, when you're choosing a project topic, you have to figure out basically what you want to do is you want to demonstrate your mastery. Remember that this is kind of like something you can use as a portfolio project. You can use this for like interview. This could be a good one to say that you're interested in this aspect and that you want to, what's it called? Like, the way I describe this, like, pick a topic that is important to you or that you're at least interested, so that when you're done with this and someone in an interview asks, like, oh, tell me about a machine learning project you've done, you can pull this out of your hat and say, oh, well, this is a really great one I've done. And you can talk at lengths about, you know, the intricacies and like what challenges you had and how you overcame those challenges. So the more interested you are in it, the better. Don't just pick a topic because it's like, oh, one, it's like, you know, if it's really easy, like, you know, give yourself a little bit of challenge, right? But two, also make sure it's not something just like, oh, it's going to sound really impressive, but you have no interest in it. So just kind of be aware of those things. Okay. So again, this kind of adds, like, it really does help you stand out in the sense, especially if like experience is a big part where you're like, you're going to compete with people who do have direct experience. Projects are a great way to demonstrate that experience. Okay. So the big thing is like how to choose a topic. This is where you can go between like professional experience and personal passion. If you really don't know like what you want to, like if you know what field you'd want to go into, that's when you might pick specific professional experience. So you might look at, if you want to go in finance, you might look at specific like financial transactions and look at that kind of thing, or some retail commerce. So that's something that you might actually specifically look at. Otherwise, you know, I think a good one if you're really not sure is do a passion project, like a project, because a lot of these concepts still carry over, even if they're not specific to this professional experience. You showing that you know how to do machine learning in this aspect, being able to explore, that still carries over to a lot of different domains. So if you're specifically interested in a certain part, I know a lot of people, for example, are really interested in sports and they would go into specific parts of that, but you can do a whole bunch of different things that are interesting to you. I think someone did something about archaeology because they did an archaeology, I think they had an archaeology PhD, and they basically did something that was related to archaeology because that was something that was passionate for them. Even though it wasn't directly related to maybe a professional experience that they wanted to go into, they knew they could talk at full lengths about it and they can do the nuances of that machine learning project. Okay. So that's kind of choosing your topic. This is where this criteria, I think the curriculum might show something slightly different. So just kind of know that I'm going to state this stuff. I think it's a really good, again, I didn't come up with this myself, but I think it's pretty solid. So for this project, 50,000 rows for like at least 50,000 elements. So if you have less than that, you probably won't get good results for the machine learning. Like you might, but there's a good chance that you just won't get any meaningful results and it'll be difficult to know what to do with it. If you have too many data points, I would say past 200,000 might be a little too much in the sense of like for this kind of project, because you'd have to consider, you know, does your computer actually be able to handle all this information? Remember that your machine learning algorithms are going to probably use a lot of processing time, right? So it might take a long, long time if you have too much data. So this is more like, in a lot of ways, I like to say a proof of concept to show like, can you build a machine learning project? And you can still get some really meaningful data from just 50,000 to 100,000 rows of data, okay? This one I'm going to say it's a must. You have to have at least 10 continuous features. So continuous mean like numerical features. So not just simply like categorical. So this way you can actually do feature engineering. You can actually get meaningful stuff. If you have less than 10 or at 10, it might just not be, honestly, it might be underwhelming of any insights you can find. So it's kind of good to actually have enough features to go off of, okay? So I would say at least 10, okay? Again, like it says, less than 50%, or sorry, they said cannot be more than 50% categorical. That's again the same way. It's like if you have too many categories, it's just not gonna, it's gonna be hard to actually like pull anything interesting out of it for this project, for the scale. Not to say that if you have other projects in the future that have a lot of categorical information, you know, that's not a bad thing. But I think for this practice, for this project, especially putting it as a portfolio, I would try to avoid having a majority of categorical features, okay? Last one, I haven't had too many people try to do this, but try not to do your own data sets right now. Like don't try to use like an API. I'm sorry, like don't try to like collect, like web scrape this information just because it adds an extra layer. I don't think anyone like is planning to do that, but if you had like high ambitions to be like, oh, I'm gonna do this API, I'm gonna web scrape, you know, this information, I'm gonna combine these different data sets, I would strongly suggest not doing that. That way you can focus just on the machine learning aspect of the project, okay? For capstone, that's a different story. Maybe we talk about, you know, what to go from there, okay? And this format right here, this is minor. The things that, just know that whatever you're talking about, if it's CSV, if it's a JSON format, if it's an API, how much effort is it going to take you to actually read that information into your project? So if it's going to be like a JSON object or an API, this is going to be something that you're going to be able to do in a reasonable amount of time. Just kind of be aware. I don't want you to get stuck on just doing the data stuff when I want you to be able to do the parts of the machine learning aspects. Okay, cool. Sound good so far? Yeah, see nods, cool. All right, so some things to avoid. Keep this for at least this project. Natural language processing, so anything like with doing semantics and stuff like reading like data. Again, these are all problems that are really great problems. It just would take you a lot longer than probably the time you have available for this one project. So natural language processing, computer vision, basically anything with images. do-it-yourself data sets, right? Anything that you're kind of trying to collect all yourself. Anything that requires human input. That's a big one, is that it actually goes a little two ways. One is that if you have to call the API many times, or you have to adjust things to get the data set to where you need it to be, avoid that for now. Other aspects is that if there are things where to get the data, or the way the data was generated was user inputted. So for example, if there are things like a bunch of Twitter tweets or something like that, that would be NLP. But let's say there's a bunch of tweets, I would avoid doing that, just because people mess up. And when people mess up, it makes it difficult to make sure you clean up that data. And this is where you might want to avoid trying to, remember back on our very first project, trying to do all that cleaning to take a long time. You want to try to avoid doing that part. So this is where some suggestions, and these are pretty consistent, like different sectors that have pretty good clean data sets are education data space, or education space, government space. So anything like with a government website usually has some pretty good clean data. Scientific data is usually very clean. However, note that if you do get scientific data, it might be something you might need a little background research to understand it. And this, for example, you wouldn't do this specific one, but one, for example, someone had were different x-rays, and it was very well documented and understood, but that's because it was under a scientific research paper. But so these are ones that are really easy to go off of. Government, again, government data, educational data, or scientific data. Okay, you don't have to follow this, but these are good kind of rules if you want to avoid this extra messiness. Okay. All right. This is, is anyone familiar with Trello? Okay, so actually not as good. So you can see it is a Trello board. This can be really useful when you're trying to organize your thoughts and make sure you're getting everything done. So I would definitely try to use this. I use this in my own personal workflow. You might have a different workflow, but this might help you when you're trying to go between getting the data and then actually scrubbing it, doing exploratory data analysis, and then doing actual prediction. So for this project in particular, I want you to take, in reality, you probably would take a lot more time in this aspect, scrubbing an EDA. But for this project, I want you to try to focus as best you can into closer to the end part, because we haven't done this aspect yet, or at least haven't focused directly on here. So these are things that maybe try to make this as easy as possible for you, but it's good to organize this information. Okay, cool. Any questions so far on anything I talked about? Pretty good. Cool. So last part is like, okay, you kind of got an idea of like what you want to do, right? Maybe you have an idea of a concept of what you'd be interested to look at. Where do you get this data set? So I know for the fact that the, the curriculum shows a few resources. So UCI, UC Irvine machine learning data sets, really awesome. So I'm just going to quickly show you what this looks like. Oh, that's not going to be it. So let me go ahead and copy it from here. So if you just look up for UCI data set, no, maybe not. There we go. So you can see they have a huge amounts of data. They have a lot of different data set going through here. They're all really, a lot of them are well documented. Note that some of them only have like, this is only 226 different instances. So this might not be the data set you look for, but you can see there's a lot of data sets that are relatively good sized. This one's almost 50,000 and stuff like that. There's number of attributes, number of features, and they have a good collection of all this different information. So this is a good one to check out. Another one to talk about is Kaggle's data sets. So I think I might have mentioned Kaggle before with finding data. Oh, there it is, kaggle.com/data sets. So if you go to kaggle.com, you guys are familiar at this point, click data sets. Kaggle actually has a lot of data sets. It looks like 2,000 or 21,000 data sets. So you can actually pull this information up. And so if you're like, for interested, like I'm interested in bikes, right? Bike transportation. So just do like bikes, right? And just see what kind of data sets pop up. You can see different bike share analysis, a whole bunch of bike share stuff. So there might be something about like, accidents, for example. Say, okay, well, if I do like bike accidents, I don't know, see what pulls up. Okay, so it looks like you might have something informative there. These are usually nice. Usually Kaggle does a pretty, usually Kaggle data sets are pretty good at one, making it nice and clean. Nice, easy to like pull this information. You can download this info. Note to download, I think you usually have to sign in. So you might have to register. You don't have a Kaggle account. Also, what's nice is that if you go back to here, you can, oops, that's not what. Let's just do bikes. So if you look here on the side, you can also see different votes. So you can actually see, for example, this one's actually maintained by Kaggle. So this is actually within their site. You can also see people comment on them, vote them up. So you can get an idea of like how much like traffic goes through this part and knows that if it's a decent enough project. And what's also cool too is that you might see people actually use different kernels. For example, you can see different kernels here. Maybe people that already done some little bit of exploration. They help motivate you. Definitely, you know, honor system, right? Make sure it's like stuff that you generate yourself. But if you're kind of like, you know, let me see what other people have done with a similar data set, you can check out some of these kernels. So that's really useful for Kaggle. A couple other ones like are on here. I think this is directly from the curriculum. So like awesome datasets repo. So that's actually on GitHub itself. New York City open data portal. So that one's actually got a lot of good information. Inside Airbnb. So they actually provide a lot of this information. Data World is also, no, it's not going to show up. There it goes. Data World is also a really good one to find data from. So this is kind of similar like a data aggregate. And then there's one last set that I'm going to throw in here. It's not really a data aggregate, but it's literally Google for data sets. So you can see here it's this. If you just literally search Google Google data set, this basically has a little part, and what you can do here, you can actually type in just like you would do with Google, and you would say, okay, bikes, and you can see there's basically all this information, and basically it's pulling up different data sets collected from different parts. So you can see Kaggle, for example, shows up quite a lot, but you can see some extra stuff. For example, this is data.gov. So you can see here, this might be some useful information. You can actually check out the actual website. So you can say, okay, let me check out this part. And you can see if this data interesting to you. You can check it out, see if it's useful. I find that's really fun to kind of like just find different random data sets in here. So I would kind of say like, if you're just want to explore a little bit and see like what's out there, this is usually a good one to start off of. And this is relatively new. I think this is only about like maybe a year and a half old. So not that it's in beta, right? Just like everything in Google. So cool. Do you guys have any questions about finding data sets, what's required for this project in data set wise? No? Okay, cool. And I realized I got the page up here, so I'll show you what the actual summary goes on here. And I just looked at it right here. Your data set should contain a minimum 1,000 rows. No, it needs to be much more than 1,000 rows. 1,000 rows is way too small. You will not get meaningful work. So I would say 50,000 is pretty solid in the sense of doing for machine learning. So definitely go in that direction if you can, as much as possible. You can play around with something that's smaller, but for this project, to make it worth something, at least 50,000. Okay, cool. All right, so no questions then? Okay. And again, just using the data science lifecycle, that's how the way you want to approach. This project will still have your Jupyter notebook, your technical aspect, right? Note that we're also going to talk about README, so make sure you actually have a README. We'll talk about maybe for one of our office hours, talk about what that looks like. This is your, was it your 4th blog post now? So this will be a blog post that's associated with part. And then, of course, your non-technical presentation itself, okay? As well as the recording of your non-technical presentation, okay? Cool. All right, so I guess I'll go ahead and stop it here then, right? Unless you guys have any other questions.